Okay, folks, let's take a look at this problem where we have variable times on the durations. So if you read through this problem, what you're going to notice is you're not given a set duration for each of these activities. What you're given is you're given an optimistic time, a pessimistic time, and then a most probable time. And so the way this works, it works very similar to what we just did in problem 5.2. But what you're going to have to do is you're going to come up with what's called an expected value or an expected time for each activity, and then go through the exact same thing we did in problem 5.2, which was go through the forward pass, the backward pass, find the activities with no slack, and then identify your critical path. The thing that we need to talk about first is how do we find this expected value? And there's an equation that you'll go through. Like I said, make sure you're going to go through the reading very carefully, and perhaps you'll find all of these in the PowerPoint slides, and you can just keep these handy as you're doing your homework. But let me just show you, and I'll give you my spreadsheet here. Effectively, what it is a weighted average. So what the expected value, or in this case, the expected duration is. If I look at the optimistic time, the most probable time, and the pessimistic time, the optimistic time is value or variable A, most probable is M, and the pessimistic time here is B. So if you look in the book, you'll find an equation that says that the expected value is A plus 4M, which is here, plus B divided by 6. So that is the formula I've used here for activity A to compute the expected duration. And again, the beauty of this, if you do it with cell references, after you do that, if you just take, let me prove this to you. If you just take this cell, put your cursor in the bottom right, and just pull it down, it will copy all the way down and give you the expected durations for each one of these projects. So the critical activity, so what are you going to do to answer part A? You're now going to go through and do exactly what we did in problem 5.2, only you're going to use these values as their durations, and obviously you still have the predecessors. If you do this correctly, based on this information, you should come up with an expected time or a duration of 26.33 days. In addition to that, what you need to do is you need to compute the variation for each one of the activities. And again, if you go look in the book, the variation for each activity is computed by taking the pessimistic value minus the optimistic value, dividing that by 6, and whatever that value is, whatever that quotient is, you square it, you get the variation. And like I did before, I guess I can probably delete that without losing the coloring. All you need to do is pull that down, and then you will have the variation for each activity. That's what I was afraid of. Let me just go back here a second. Let me go back. I don't want to do that because of what I wanted to show you here. So again, you can pull that down, but what I wanted to show you here is that, again, if you do this right, what you're going to find is that activity A, activity D, activity G, and activity I are on the critical path. That was my coloring scheme here. I don't want to lose that for you. Why are these values important? We'll talk about that here in a minute. So what are the critical activities? You should be able to find that if you go through this correctly. What is the expected time? Again, if you go through this correctly, you should come up with 26.33 days. Then it says, based only on the critical path, what is the estimated probability that the project can be completed in 26 or fewer days? Now, in the book, what you're going to find is there is an assumption that the distribution of project completions completion times follows a normal distribution. So this is going to take you back to your statistics days. And so in the book, it explains that you're going to compute a z-score, again, which is, if you remember from your basic statistics course, remember z just measures some number of standard deviations from the mean. So if you use the basic calculation of x minus mu over sigma in this context, the z value that you're going to be computing so we want to know what is the probability that the project can be completed in 26 days or fewer. So if X is 26, the mean here, mu, is essentially the expected value of 26.33 days. And then the standard deviation down here in the bottom, notice I've used the square root because what I've done is I have computed the total variance of these 4 activities. So if I take the square root of that as the denominator and I go through the calculation, the z-score here is minus 0.26. Now you can either, and this is confirmed by looking at the table. If you can either use a z-table to find the area to the left of z, which would tell you, or would be the number, or would be the months that are less than 26. So if you look up z equals negative 0.26 in a z distribution table, and you look to the amount of area to the left of that, or you can use, notice there's a normal dot distribution function built into Excel that all you need to do is feed it the x value, the mean, in this case the standard deviation with 1.27 is the square root of 1.61, and then if you say true, it's going to give you the amount of area to the left of negative 0.26 in the standard normal distribution, and that's about 39%. So the probability that the project can be completed in 26 or fewer days, that probability is going to be about 0.39. And like I said, if you look up the z-score of negative 0.26 in the z-table, you will confirm what I did for you here in Excel. The last problem here. So this is kind of a fun one because you get to kind of play a little trial and error here on a small project. So this is the problem where we have a project that needs to be done within a certain amount of time, and what I did is I copied the project out of my homework set. Again, I don't know if your activity predecessor is going to be the same, or the normal time, crash time, normal dollars, crash dollars are going to be the same. But what I want to show you is the approach here. The first question says to develop a project network. Remember, the project network is this visual piece here, so you're going to have to find one of the, I believe that you're going to be asked to identify the network, the project network in the homework. So make sure that you're taking a look at something like this as that activity. Then you're going to develop the activity schedule. I have actually already done that down here. Again, I'm not sure if your value is going to be the same, but it looks like that we've come up with a project duration of 31 days, and it looks like we've got some activities here on the critical path. So that will help you with C, or this chart will if you have different values. Then it says, assume the company wants to complete the project in 26 weeks, same thing as 6 months. What is the amount of crash time in weeks for each activity that minimizes the cost? And so what we want to make sure that we're looking at here now is the normal duration for these activities is shown in this normal column. And what the company is saying is it looks like we can add some resources, and we can take activity A from 10 weeks. Let me see. Are we talking about weeks? I think we are. We're going to go from 10 weeks to 8 weeks. We can go from 8 weeks to 6 weeks with additional resources for B, so on and so forth. Then it says the normal cost for this activity is $30,000 if we do it in 10 weeks, so on and so forth. But the crash cost here obviously is going to be a little bit more, so $70,000 with the crash approach here. So what I have done, let's see, what did I do down here? The thing that you're going to have to do here is that you're going to have to come up with a weekly cost. Yes, it is weeks. I knew I saw weeks. So what we're going to do next is we're going to come up with a weekly cost for the crash routine here for each activity. And so the way that works, obviously you take the number of dollars here that is different. And again, there's some formulas in the reading and in the PowerPoint presentation that you'll find. So if you take the total dollars and divide that by the total time saved, so $40,000 divided by 2 weeks. So the cost per week for a crash hour for activity A is $20,000. Let's see, let me just do one more of these to make sure it makes sense to you. Total savings here, or the total cost here, is $30,000. If I divide that by 2 weeks, so $15,000 a week. Sorry about that, for activity B, and so on and so forth. So make sure you come up with all these costs per week. The next thing is, in the discussion in the book kind of goes like this. If you have a small project like this, and again, we're just trying to understand the basics of this. If you have a small project like this, you can kind of do it on a trial and error basis. But if you have, let's say you have 40 or 50 activities, that might be a little more challenging. And so there's a good element in the reading that will take us back to the linear programming days, because as you note here, the goal here is to minimize cost. And that should, again, it should take us back to the linear programming days. And there's a discussion in there in how you build this model. But from this standpoint, what we want to do is we want to figure out how to go from 31 weeks to 26 weeks and what is it going to cost us. So if you take a look at take a look at this chart that I've done for you here to compute the forward pass and the backward pass, I have done this one. This is kind of a formula based where this one back here, I just did a little addition and subtraction. There's no formulas in here, but I set this one up with formulas so that you can kind of play around with this, with the goal that ultimately here's what you're going to land on, is that you're going to crash, or you're going to use 2 weeks of activity A crash time, 2 weeks of activity B, so on and so forth, and it's going to cost you. Looks like it's going to cost you, let's see, $112,000 to do this. But here's what I want you to do from a kind of a mental and a conceptual standpoint. Remember that the reason that we compute slack is because we want to know the activities that are critical, and if they move, if they extend, or they decrease in duration, they should have an impact. They should have an impact on the overall duration. So if I was just going to go in here on a trial and error basis, what I've done is I've copied the original durations over here, so you can reset this. But I hope you will play around with this a little bit. And notice that when you impact the activities that are on the critical path, you should, if you decrease these durations, you should decrease this this overall duration that we computed based on the standard duration. So let's see. Let me just pick. Let's see. I've got AB. Let's see, ABC. Let's see, activity D and E both on the critical path, but they're cheap. Imagine that. So we can't get to the cheap ones right away. So let's just go up here and see what happens if we buy 2 weeks of crash time on activity A. What does that have, or what happens in that regard? So notice the duration would go from 10 weeks down to 8 weeks. And notice what we did. Well, for week, we bought a week of schedule improvement. So we've got 2 additional weeks there. We're not down to, let's see, we want to get to 26. What happens if we buy 2 weeks of activity B crash time? So this would go from 8 weeks to 6 weeks, and hopefully we're going to get a decrease. That's great. We went from 29 to 28. Notice also, because I've got this formula base, notice you're going to see a little bit of change in the critical path. That's good. But ultimately, again, just play around with this. But what happens if you, let's see, let's go back to the original. So this was 10, and this was 8. And what you notice here, if you look at the optimal solution, so if I go from 10 to 8, if I go from 8 to 6, if I go from 10 to 9, if I go from 7 to 6, and if I go from, let's see, 10 to 9, that's actually the magic that I need here to get myself to 26 weeks. And there is the additional cost to crash the project and go from 31 to 26 weeks. So I hope the way that I've set up this matrix here, you can play around with this, have a little fun with it, and understand what happens when you start when you start looking at the activities that are on the critical path. So again, I hope this is a fun and practical week, and hope you enjoy it. Take care.